Second part of this hands-on, we will configure low power timer 3 to measure signal which is generated by low power timer 1. Period will be evaluated from rising edges on channel 1. Data cycle will be evaluated from falling edge, and what is necessary to say is that both flags of input capture for input capture event will be cleared by LPDMA at input capture 2 event. It's same situation as with update event, because these flags are not cleared automatically. For this step, it's necessary connect together output from low power timer 1 to both inputs of low power timer 3. It may be done by 3 wires which are tied together with the short. And now we will enable low power timer 3 for input capture on both channels. And only necessary change is change polarity for channel 2. Back to the IOC file. Pinout and configuration, low power timer 3. We will count internal clock event and use both channels as input, and for channel we change polarity to falling edge. That's it. What we can check is connection to pins. It must be on PF2 and 5, but it is default setting, and we can see that this connection is here. Now we will enable next 2 channels of low power DMA. It will also be in circular mode as previous 2. Linked list mode, and channel 2 also be circular, channel 3 as well. It's done, and now we add new queue for timer 3 for input capture 1 with 1 node. We will also use cheat sheet this will be better for input capture 1. Linked lists are at the end. At list, new name, low power DMA, circular, and first node is IC1 node. And this name of this node. Request will be from input capture 1, transfer will be for compare capture register to memory, 4th byte, and we need to store 2 values, then we must increment the destination address. Low power timer input capture 1, peripheral to memory, board UART, destination enable incremental and word byte. No data handling, no triggering, but it's necessary to set address for this transfer. Source address is compare capture 1. It will be stored to this variable, and data size will be 2 times 4. Next step, it's add new view, new list for input capture 2 with 2 nodes. One will be store data, second one will be clear flags. This is very nice feature of the linked list programming of DMA, because we may do more than one operation, and it's sometimes really easiest the programmer life. Q low power DMA circular, and first node is IC2 node 1. The request will be from input capture 2, transfer will be from peripheral to memory, only one word will be shifted from compare capture register to variable. Not software request, but input capture 2. From peripheral to memory, word byte, and source address will be compare capture 2 register. Variable, and data size is 4. And now we have to configure the second node for this linked list. Then we will not generate code now, but we add node, and we change name. And this transfer will be requested by software, respectively it will be requested by ending previous transfer. It will be from memory to memory, but in the fact to the register, and one word byte. No data handling, source address will be this variable, and destination will be input capture register, and data size will be 4. And the last hardware change is clock setting for the low power timer 3 to LSE. We are using LSE because at the end we will stop the core and only oscillator which may be used in stop 2 mode is LSE. I want to be sure that everything is stored, and we will change LSE as source for low power timer. That's it. Now we can save all changes in IOC and generate code. At the start we must modify the main header because there are more variables. Definitions are the same. Okay. Next modification is for linked list, because we created new nodes and regenerating the IOC file. All definition which was cleared because it's not in user code, then we must put it there once more. As I say, as RAM4 it's only RAM which may be used for low power DMA, low power peripherals as buffers when we need to work with in the low power mode. Now we will modify main C file. I will make next few steps by this cheat sheet. First are new private variables. And we will enlarge the user code section 2 for bytecode for control low power timer 3 and its DMA. And at the end to user section 3 we will add some code which calculates from stored values of falling edge and rising edge the period and data cycle. That's it. Now we can build the code and start debug. Run. And I have prepared in live expression showing of variable data and period which are measured from the input signal. If I disconnect the signal, there will be last version. If I connect it by hand, there is some nonsenses from the pair, and there are back our values.